Greetings to all. I am Mrs. P. Ramalakshmi, Assistant Professor of ECE at Kamaraj College of Engineering and Technology. Let us see about GSM architecture. In this lecture, we will discuss about the fundamental components present in the GSM architecture. First of all, what is GSM? GSM stands for Global System for Mobile Communication. It is a 2G digital mobile standard which was developed by ETSI. It provides services like voice calls, SMS and limited data services. It uses the SIM cards to identify the user and it operates in the frequency bands of 900 MHz and 1800 MHz. GSM is known for enabling the international roaming and secure communication. Let us see the small history about GSM. Already I said GSM was developed by ETSI in the year of 1980s. ETSI stands for European Telecommunication Standard Institute, and the aim was to create this one, a common mobile standard across Europe. The first technical specifications were released in the year of 1987 and the first GSM call was made in 1991 in Finland. The GSM services, it provides a range of services like basic voice calls, SMS and the supplementary services like call forwarding, call waiting and caller identification. It also provides circuit switching data services and GPRS for packet data transmission. So, this is the layout of GSM architecture. It consists of MS, BSS, NSS and OMC or OSS. So, now let us move on to our core area in our session, that is the basic system architecture of GSM. So, in the basic architecture we have four main components. One is mobile station, base station subsystem, network switching subsystem and operation and maintenance subsystem. The mobile station, it consists of two elements, SIM and mobile equipment. Mobile equipment, it is nothing but the physical device, that is our mobile or modem which is used for communication. Every mobile device has a unique number, that is IMEI, International Mobile Equipment Identity Number. It works with a SIM card to access and authenticate the service. It handles radio communication, signal processing and user interface. SIM, it stands for Subscriber Identity Module. SIM card is a removable smart card which can be inserted into the mobile device. It also has a unique number, that is IMSI, International Mobile Subscriber Identity Number. It provides the security, allows authentication and retains the user data. So, the next is our base station subsystem. The base station subsystem which connects the mobile device to the network switching subsystem. It consists of two main elements, one is BTS, another one is BSC. BTS, base transceiver station, which is responsible for transmitting, receiving signals to and from the mobile devices. It consists of radio transceivers and antennas and handles a single cell in the network and which is interface with the base station controller to forward the calls and manage connections. Base station controller, which is the brain of the base station subsystem because it manages the number of PTSs and controls their operations. The operations like frequency allocations, handovers and power levels. The next one is network switching subsystem. It is responsible for switching the calls and data and managing the user locations and supports mobility. It consists of number of databases like Mobile Switching Center MSC, Home Location Register HLR, Visitor Location Register VLR, Authentication Center AUC, Equipment Identity Register EIR. MSC, Mobile Switching Center, it is the central hub or central node in the NSS. It handles call setup, routing and termination. It manages mobility, functions like handovers and location updates, and it interfaces with the databases like HLR, VLR, AUC and EAR for subscriber information. Also it connects GSM network with external networks like PSTN and ISTN. Home location register HLR, it is a permanent database which consists of the subscriber informations like IMSI number, current location and the services. Next one is VLR, visitor location register. It is the temporary database. It stores the data for subscriber currently within the MSC zone. That is, it pulls the data from the HLR when a new user enters the MSC zone and deletes the records when the user leaves the zone. It improves the performance for roaming user. Authentication Center. Authentication Center provides security by verifying the subscriber's identity by using the challenge response mechanism. It also generates encryption keys for preventing from the fraudulent access. Equipment Identity Number EIR. It contains all the identities of mobile equipment and it can block the blacklisted and stolen devices from accessing the network. OMC or OSS, Operation and Maintenance Center, which is responsible for monitoring and maintaining the GSM network, and it manages the smooth network management by managing the fault detection, configuration and performance analysis. It also provides software updates, remote diagnostics and managing subscriber data. Till now we have seen about the fundamental components present in the GSM architecture. Now we will see the flow of a process. That is our mobile station which is communicate with the base station subsystems component BTS by using the UM interface. UM interface is nothing but air interface. So through air interface the mobile station, our mobile device connects with the BTS, base transceiver station. Further the base transceiver station connects, that is sends the information to the BSC, base station controller. Then the base station controller makes the connection with MSC by using the APIS interface. So MSC is the brain of the network subsystem. So it will connect with the external network like BSTN, ISTN, BSPDN, CSPDN. As a mobile user, we must know about how the signals can be transmitted from one end to another end for our communication. To conclude, the GSM architecture is a robust and a secure system and that laid for new modern technologies. Thank you for watching.